Thanks very much for your time, colleagues. I'm Mike Anthony from Ann Arbor, and we have Dave Panning from BIFMA, and he will be presenting an overview of educational furniture standards. Go ahead, Dave.
Thank you, Mike. Pleased to participate in this. This is my third one with you, and always happy to accept invitations. So today I'll discuss with you, Mike, and I think you're going to share this with others, an overview of educational furniture standards. Just to clarify, BIFMA is the Business and Institutional Furniture Manufacturers Association. Institutional is often associated with educational, healthcare, and whatnot. Business is more with the office and whatnot. So our membership deals with all three of these. And a little bit about BIFMA. We do have over 300 members, largely manufacturers that produce office and institutional and educational furniture. So I'm going to give an overview of BIFMA. We'll talk about the American National Standards Institute process. Then I'll discuss some of the ANSI BIFMA standards that are often used in the educational community. I'll share also with you upholstered furniture flammability. That is not an American national standard. It is not a national standard, but there's some California standards that are widely used, and I'll discuss that a little bit. And then I'll just mention there are some international standards for educational furniture. So BIFMA was founded in 1973. We have over 300 members. There's three primary tests that we do. We develop voluntary product and industry standards. We advocate on behalf of the industry with legislators and regulators, and we publish industry statistics. And we're an accredited ANSI standards developer. I understand from you, Mike, that there's about 7 of us in Michigan. What that means is when we develop standards, it's not just BIFMA and BIFMA members, but it is users, universities, government, test labs, so on and so forth that participate in this process. It's very open, there's balance, there's a rigid process that we have to conduct in order to implement an American national standard.
Yeah, to add to that, Dave, I try to drive home the point that when you're accredited as an ANSI consensus standards developer, you've effectively met ANSI's criteria for creating a balanced democracy, that the intellectual property that you develop, and it is intellectual property, as you well know, that you've had a balanced set of stakeholders that have had input, can respond to proposals, they have a way of making appeals if you don't like the result. And it's important because an ANSI standard is required by law to be the first choice for any organization, particularly those that are charged with public safety. You have to first go to an American national standard before you try writing a standard of your own. So it's always important to realize that this is essentially, you're writing regulations, but it's writing regulations among those who know the most about a subject, rather than those at a distant place somewhere near the East Coast. So anyway.
Yeah, that is correct. The government, and I think this is great, the government's asking that the stakeholders make the standards rather than someone in an office say this is a regulation, this is what it's going to be. And actually there's lots of benefits for society in that being the case, so we're pleased with that. So I've listed standards that I'm going to cover today. There's several seating standards. There's standards for files and storage units, desks, tables, panels, furniture emissions, furniture sustainability, which are newer to the furniture community in the last decade or so, and then the ergonomics guideline. These are widely used in the educational environment, or at least most of these are. So the first seating standard I want to mention is the, we call it the X5.1 general purpose, and this is largely for chairs that have a lot of adjustability. These are working chairs used primarily in the office and business environment. In an educational facility, you probably find these in the administrative offices. It's based on the 95th percentile male, and that's how the tests are developed. And I'll be talking about the various tests as we go through these. Next one I want to mention is the X5.4 lounge standard. This is usually for seating products that are less workhorse products, but more comfort, and you'll find them in a lounge, a gathering spot, and on campuses. I think you'll see these in the student gathering rooms and waiting rooms for the administrative offices. This is a new one, so I don't think it's been widely specified, at least as of yet, but it's getting out there. It's been out there for about 2 years, and it's the large occupant seating standard. And this is because of the market's demanded it. We're getting bigger, and I'm going to talk about that a little bit further down when we talk about ergonomics. But it's based on a 400-pound male as the basis for the chair test. The BIFMA standards are almost exclusively performance-based. This is one exception. This standard does have a design requirement. The seat width must be at least 22 inches, and the ergonomists kind of came up with that number. Actually, they'd like to see it a little bit larger, but with arm wrestling through the ANSI process, it ended up at 22 inches. And we did these development projects with Mississippi State University. Mississippi is the state with the largest subset of the population. So they were very cooperative.
What you mean is that Mississippi, the demographic there provides a lot of data for large occupants?
That is correct, Mike. That's probably a better way of phrasing than how I might have said it. So, yes. And the fourth seating standard that we have is the educational seating standard. And this one is new. It came out in 2012, so that's relatively new. And it's designed actually to incorporate smaller sizes. So on my graphic here, you can see size A is for the very small age group. This would be kindergarten, first grade, and so on. Size B, we're getting in up toward the middle school size, and then size C really is adult. And size C, a lot of those tests are the same as the X5.1 standard that I mentioned earlier. So I'm going to go through the tests, and I'll go through these quite quickly. But there's roughly 20 tests in each of these seating standards. Many of them are similar tests, but the requirements vary a little bit, and the method of test may vary a little bit, but they're very similar. So one of the very common tests is the Backrest Strength test. And basically, as you can see from the graphic, there's a force pulled on the back, and it's a very high force. And this is a tough test. Labs will say that this test alone will often weed out bad chairs. There's a drop test, and this simulates someone dropping into their seat as they sit down. Especially the younger folks tend to do this. As people age, they might sit down more gingerly. But so it's got a very heavy weight that's dropped from 6 inches, and this is probably the second most onerous test. The Backrest Strength and this drop test, these are often the first two tests the lab will do, and if they pass these, they'll continue the test program. Often they'll send a chair back to the manufacturer saying, you're going to need to redesign because it didn't meet these. So these are two tough tests. Then we get into some durability tests where we're looking at cycles rather than incredibly high weights. The weight is less than in the drop test, and it's cycled tens of thousands of times into the seat. I believe this test is 140 20,000 cycles, 100 in the middle and then 20,000 on each front corner. This is a stability test to simulate someone leaning back in the chair, and we really worked globally on this test. We've worked with our colleagues overseas, primarily from Europe, in developing this test. And it's a series of discs placed in the seat, and as you load the discs, chairs with flexible backs tend to lean backward. So it truly is I've heard it's a great test. Chairs that don't pass this are problems in the field. Chairs that pass this generally do not have issues in the field. Conversely, there's a front stability test, and this simulates someone perching to the front edge of their seat, maybe to do something on their desk, or as they're about to get out, they might scooch forward. Again, we've worked with our European colleagues, and they've figured out that a distance of 2.4 inches from the front edge is about as close to the front edge you can get off to it without falling off. And so there's a disc that's strapped to the seat, and the forces are applied to the center of that disc. And so again, see if the chair tips forward or not. There's arm strength tests. There's a vertical force. There's also a horizontal force. And one can imagine the different forces that people could put on chairs. You can envision someone sitting in a chair and someone tugging on it, or sitting on the arm itself. If you can think of the possible scenario of someone on a chair arm, they do it. We hear about it all the time. Also, the chair leg strength test. There's a force applied to the front of the leg, and then there's a repeat where the chair is turned 90 degrees relative to the photo you see, and it's applied to the side of the leg.
So Dave,
this is another...
I'm sorry, Dave, as I look at these tests, these are generic commercial furniture tests, and then I imagine that the educational seating, and I'm thinking of young people, elementary school, or even high school students, that's a different classification for the strengths? Are they roughly the same?
I mentioned the sizes in the educational seating standard. For the adult, they're the same.
Okay.
The forces are less for the smaller sizes, although they're not proportional. For example, the very small chairs, if there's no arms, well, we often hear of parent-teacher conferences where the parents come into the classroom and guess what they're sitting on in the kindergarten rooms? They're sitting on the little chairs. So
yeah.
The forces are less, but there's also consideration to the occasional use from an adult.
Yep. Thanks.
Backrest durability. I showed the first graphic with the backrest strength. Those are one-time high forces. This is a force, and the graphic I'm showing shows a 100-pound force. It does vary on the size of the chair, but it's applied for 120,000 cycles. And I should add that the ANSI BIFMA standards are almost all predicated on a 10-year life cycle. So the folks on the ANSI consensus body, they do calculations based on how often do people lean back and get in and out of chairs and this and that when they come up with these cycles. But it's based on 10 years of use. There's a test called angular armrest durability, and this is strictly to simulate people getting out of the chair. Someone's putting both arms on the armrest and pushing themselves up and out of the chair, and that's done 60,000 times. There's a structural durability test, and this simulates moving the chair, racking it side to side, and the chair is restrained at the base, and then it's pushed back and forth 50,000 times. Swivel test. This is probably more relevant to the business community, but again, the educational seating standard does include this because of the administrative uses, and this chair is swung back and forth or testing the swivel mechanism for 120,000 cycles at the highest and low positions if there is adjustment. And the tilt mechanism, this one's not even in the educational seating standard, so this one really applies more to the business community. And caster durability. This graphic shows a chair with a weight in the seat, and then it's cycled back and forth on this platform. The platform shows obstacles. These are 1/8-inch high metal bars. Actually, the chair's tested most of the cycles without those metal bars, but then there's several thousand cycles with those metal bars in it. Now, not part of the BIFMA spec, but just want to mention that there are various caster options out there for specifiers. There's casters that people specify for use on carpet. There's casters for use on hard or tile floors. There's also braking and non-braking casters. For example, a braking caster would be such that when the user stands out of the seat and there's no weight on the seat, the brakes engage. They found that some people get up and out of chairs and their back legs bump the front edge of the chair rolls 3 or 4 feet away, and then when they go to sit back down, the chair is no longer there. So these are just caster options. Those last few I mentioned are not in the BIFMA standards, but can be found elsewhere in some European standards. Very common in the educational environment are tablet arms, and there's a static load test where a one-time heavy load, and there's also, I'll call it a durability test with lower loads, but tens of thousands of cycles. If there's seating products with footrests, as might be found in chemistry labs or engineering type technical labs, sometimes you'll have these things. There's, again, a static load and a repeated durability load test. So that covered most of the seating tests you'll find in the seating standards. I'm going to move on to panel systems, and I'm going to be really brief here because what I understand from manufacturers that provide to the educational environment is panels are rarely used in those environments, but there are still some cases of panels.
Dave, on those tests, now, BIFMA's plant is not used as an independent testing lab, is it? You are actually just specifying among all the different competing manufacturers what the tests would be, right? Or are you actually sponsoring a lab like NSF Educational, for example?
We're an accredited standards developer. We do not test. We work with labs when there's questions about the standards, but the manufacturers can test products themselves, or that they can go to an independent test lab if they so desire.
Where is is there a single test lab, or who?
No, there are numerous test labs. They're all over the U.S. They're all over the globe. There's numerous labs accredited to the BIFMA standards.
Are there any? I'm thinking a lot of the airline industries, for example, would need these. Are there any test labs that are doing this in Michigan? I would have to think so because of our tradition in the western part of the state.
Yes, I live in West Michigan, so I'm very familiar with test labs here in West Michigan.
Okay.
So I'm just going to mention what's kind of unique to the panel systems. Because there's a lot of square footage typically in panels, building codes will often require flammability performance. A lot of these panels have fabrics on them, and they just want to make sure that the fabrics have some good fire performance properties. So this is a picture showing an ASTM tunnel test, widely used in the building materials market also for home products. Now we're looking at a panel stability test. You can see that force is applied at a height that simulates someone's shoulder height. If they bump into a panel at shoulder height, they want to make sure the panel system does not tip over. So that's all I had for panels. Again, it's not that applicable to the educational market, but there are some that do have panel systems. ANSI BIFMA 5.9 is for storage units, and this is primarily bookcases, wardrobes, cabinets, such as lateral files and what have you. And I'll just go over a few of those tests. One, when these storage units are applied on a desk surface, we want to make sure that they don't fall off. And so there's a separation test. This is a weight bag that is slammed into the storage unit in various locations. There are stability tests. I'm just showing a graphic of a lateral file, but these apply to bookcases and all the different types of products. And for lateral files, typically a drawer is loaded and pulled out, a worst case location, see if it tips over. I can tell you that the business and institutional furniture manufacturers almost exclusively use interlocks such that you can only open one drawer at a time. As a side note, stability for drawer units is a big issue in the residential market. A lot of home dressers have drawers that don't have interlocks, and kids will open them up at various stages and almost create a stair step to crawl up them, and they tip over. So Consumer Product Safety Commission's getting involved in this. We might get involved a little bit because sometimes the business furniture ends up in a home. The manufacturers are feeling pretty good about the interlock systems that they have. And of course, cycle tests, repeated opening and closing of the drawer units. And door tests. There are so many door tests, I'm not going to cover them all, but just by this matrix you can see the various types of doors and various tests that are conducted. Now I'm going to move on to X5.5, which is desk and table products. And these are desks, credenzas, tables, and benching. Benching might be a term that some people haven't heard. It's kind of new in the industry as more and more environments have used, I'll call it hoteling, where people don't have their own workstation but gather around in communal workstations. Folks will be sitting next to each other in long rows and working side by side, often on a temporary basis because they might be working from home normally. And so we've got some unique tests for those products too. And these almost are likened to the lecture hall long tables. I think some of those could fit this application. So stability is of course a test that people are concerned with. The graphic on the left shows a hutch unit with forces up high for something tall. The graphic on top to the right shows desk credenza series where loads are placed in the drawers and various drawers are opened. And in the lower right you can see some tables, a top view and a side view showing weights placed near the edge to simulate someone leaning down or maybe even kind of sitting on the edge of the unit just to make sure it doesn't tip over. really the worst case scenarios I hear of are the large round tables with a single center column. Those tend to be the most tippy. And unit strength tests, where significant amounts of weight are placed on tops of surfaces, shelves, and inside the drawers to make sure that there's no issues. Leg strength test. This is actually similar to the chair test I conveyed earlier. One unique aspect of this is often people will turn the table or the product upside down, and that's entirely permissible by the standard. It's just easier to conduct the test that way.
Dave, is any of this applicable or used in laboratory settings?
Oh, absolutely. You bet.
Okay.
Now I'm looking at the unit drop test, where based on the weight of the unit, it's lifted a certain height and dropped. This looks like an easy test, but I've witnessed this before, and I've seen drawers come crashing down, modesty panels separate from the top, and so on and so forth. So it's a good test, and it simulates people moving it, lifting up a little bit, and then accidentally dropping it. So again, manufacturers and the ANSI community wants to make sure these are good products that don't fall apart. In the desk market, there's a lot of height adjustability now. At the furniture shows, almost everyone has units that raise and lower. People want to go from sitting to standing. I trust that's true of the educational environment, but I actually don't know that myself. But these products have to be cycled up and down with weights in various locations on the surface. New to the tests are the addition of monitor arms, and we've added this to the 5.5 desk standard. And there's various cycle tests and types of loading on these. I'm now going to move on to furniture emissions. In the last couple of decades, and it started with the sick building syndrome in the 70s and 80s with the energy crisis, and people were just tightening up these buildings. They didn't breathe as well as they used to, for good reason. People started getting sick, and certainly we don't want to blame the furniture, but it might have been a contributor. Obviously, you had carpet and draperies and ceiling tiles and so on and so forth. So the government asked BIFMA in the 90s to participate in development of furniture emissions tests. And we started that process in the late 90s, and it took a long time. 5,000 workstations were evaluated, modeling was done, this and that. Worked with a lot of PhD folks from various universities. And in 2007, we came out with the furniture emission standard. That's the X7.1 standard. There's a method, M7.1, which is a method that's widely used even outside of furniture for how to evaluate off-gassing. And typically, most people will test for 1 week. That's what the X7.1 standard does. Others that reference this method will use maybe more days or less days in various chamber sizes. So it's a very flexible standard. It's kind of complex. A lot of calculations are involved, but I know it works from the years that people have been doing this.
Dave, let's see if I understand this. A piece of furniture emits undesirable elements and compounds. Is that what I just saw? If you go
well,
back,
no one likes to admit that, but it is possible.
Well, I'm looking at the last slide, and I'm thinking, I'm just seeing a simple chair there, and they're measuring molecules coming out of a piece of furniture. Is that what or they're absorbing?
Yep, it is. It is measuring off-gassing. This is true not only of furniture, but just about anything. So yeah, there's tests for the carpet, the drapes, the ceiling tile. as far as I don't know, maybe automotive does too. You're on the east side of the state. You might be connected with those. But so when furniture is produced, let's just take a desk. The particle board is the core material. Typically, there's formaldehyde-based adhesives to produce that particle board. Then there's adhesives to laminate a veneer or a high-pressure laminate to that core. Edge bands are glued on. Could be finishes are applied that have certain VOCs in them. So yes, there is off-gassing. Usually the bulk of the VOCs are emitted very early on, but that's why the test is conducted over 7 days to measure the degrade or the off-gassing rate.
Okay, so that's that new furniture smell we get when we roll in with a new is that fair to say? Is that I don't want to offend anybody, but you know, when you get in a new car, it has a new car smell, and when you get new furniture, is that what we're smelling? Of course, it must be.
Yes.
Okay.
Yep.
Okay.
Yep. The purchasing community has requested green. Again, this is something that's maybe been the last decade or so. And with all the greenwashing that was going on, the BIFMA community decided to have a furniture sustainability standard. And they want to incorporate, I'll say, all the aspects of green. And that includes materials, energy, human health. We just talked about human health. That's the off-gassing. And that's actually incorporated into the standard as an aspect, and social responsibility. You know, where are you getting this from, and who's the laborers or child labor, and so on and so forth. So there's roughly 100 points, I think maybe even a little more than 100 points in this standard, and manufacturers get points for achieving certain green aspects. There's a certification program along with this, and it's a marketing tool for manufacturers. So instead of NASCAR with all the various stickers, they can put one label on their furniture product, and the consumers can know that it's a multi-attribute standard. The healthcare community has really been pushing hard for this. What I've heard is the educational community less so, but maybe it's just on the edge of starting. So this might be of interest to specifiers of furniture in the educational field. I also want to mention the ergonomics guideline. This is less of a performance guideline than this one is a design guideline. This is not an ANSI requirement. This is a guideline by the BIFMA community, and it's based on principles from ISO. They use data from the Civilian, American, and European Surface Anthropometry Resource, often known as CSER. And again, it's intended to be recommendations, not requirements, but a lot of specifiers will say you need to conform to the BIFMA G1 ergonomics guideline, and so it becomes a requirement. I do want to clarify this is based on adults, not children. So I talked about the 3 sizes in the X6.1 seating standard. This really fits with the adult size only. And because I'm working with you, Mike, from the University of Michigan, I just want to put in a plug that we've worked with Dr. Matt Reed from the University of Michigan, along with other folks that have worked on this ergonomics guideline. But he's one that has been referenced a few times.
Great. Thanks for putting that in there.
Yep. So, and I'm going to go through these real quick because I see it's already 37 after, and I didn't want to go too long. These are just some of the measurements relative to a seating guideline. You can see seat width, backrest, armrest height, for example. I did mention earlier that people are getting bigger. This is, I thought, interesting data. Back around the time of the Civil War, a 70-inch tall 18-year-old male was probably around 135 pounds. During the Depression, people in the 20s, even the roaring 20s, you're looking at a same height male, 18 years old, closer to 150 pounds or so. In the 80s, we're now hitting 170, and it's continuing an upward mark. So we are getting heavier. Hence the 5.11 standard that I mentioned that came out just last year, where we have that seat width requirement. The market's pushing for seating products for larger people. So we're actually continuing down this path. The healthcare community says, well, what about the bariatric patients? So we're looking at something that's applying to the 400 to 600 pound users. This is in the works. I won't spend much time on this because I'm not sure how this fits in with the educational community, but there might be some need for it for certain people in maybe administrative offices. But we're looking at roughly 500,000 people in the U.S. over 400 pounds. Yes, Mike?
No, I didn't say anything. I just laughed.
Oh, okay. All right. And likely this standard is going to have a 26-inch seat width requirement. There are no BIFMA standards for furniture flammability, but 98% of the seating market uses a cigarette smoker test from California. It actually used to be an open flame and cigarette test, but it's changed to only a cigarette test, and I'm going to explain why. And I'll use a couple old ads to explain why. Looking at the ad on the left, here you've got a doctor talking about cigarettes. They're not going to do that anymore, of course.
No way.
You've got an ad. These are actual ads. How about this? Start your young toddler on cola earlier. I mean, you want your child to fit in if you read the ad carefully. This is just what they pushed years ago.
The Soda Pop Board of America. This is great for Throwback Thursday. Thanks, Dave.
How about this one? Mother and baby picked up Blatt's beer. Can you that?
The mind boggles.
Yeah. Now I'm a child of the '50s, so but my mom has confirmed we did not have wallpaper. DDT wallpaper for your children's room. So my point here is we're learning more about chemicals and human health and what happens to people. So when we talk furniture flammability, years ago we didn't know much about flame retardants and their effect on the environment and so on and so forth. And years ago, everybody was smoking in the workplace. Well, that's not the case anymore. So California's got some very onerous tests, and to meet these tests, the manufacturers have to use various chemicals to achieve fire retardancy. That is changing rapidly. California has just announced a couple weeks ago that they're planning to withdraw TB133, the full-scale burn test. And Boston and other regulatory agencies that have their unique codes, they're pulling back on these flammability requirements because nobody's burning up anymore. The demographics have changed in terms of, I shouldn't say demographics, but the folks aren't smoking in their offices. They're probably not smoking in the educational environments either, is my guess. So if people are specifying TB133 in the educational community, I would discourage them from doing that.
Does it cost more? It must cost more.
Oh, it does. It definitely costs a lot more.
Well, that's a little bit of a takeaway. We might want to mention that maybe on the web page. That's an important consideration.
Yeah, this comic uh, kind of says it all. Californians who have the strict flammability laws have more levels of flame retardants in their bodies than others, and these have been proven scientifically. So California, again, they're the ones that have been asking for this historically, and they're the ones that have now been saying, maybe we shouldn't be doing this any longer. So things are changing.
Mm-hmm.
I'm going to wrap up here pretty quick. Want to mention international activities. We've talked about ANSI BIFMA. Those are North American standards largely. They are used globally, but they're developed primarily for the U.S. Canadians are very active in them also, so I'll say U.S. and Canada. There's a technical committee for Furniture 136. I'm the U.S. chair and administrator for that, and there's various work groups. I'm involved in all of these, and we'll be hosting some meetings in Chicago this year. We were in Copenhagen, Denmark last year, Mike, so I did get to see some of the pretty flowers there. I know you have a passion for that.
Well, the furniture design is, I imagine that carries that sparse, elegant ethic. I think that the simple, I'm looking for a better word, but I think you would recognize Scandinavian design.
Oh, yeah,
design.
absolutely. So these next two slides just simply show some of the international standards. I can't say I know much about these. I actually just Googled them this morning. British standards, European norm, 1729. That showed up a lot on Google. There's a 7176 ignition one. That one looks like it's a little dated, though, from 1995. I saw a South African national standard for classroom furniture. There's Australian, New Zealand school and educational furniture. There's also ISO for, it looks like, functional sizes. So that's probably related to our G1. Again, we pulled from some ISO standards. I don't think we pulled from 5970, though. So my point, though, is there are educational standards outside of the U.S., but my focus today was the U.S. market. This just shows one of our successes in the international community. We've got a global agreement on how to measure chairs. There's like the crash dummy in cars. This is the dummy that sits in the chair. It weighs a certain amount. It can lean back. You can measure the angles, so on and so forth. So I'll summarize. ANSI process is very important to the validity of the ANSI BIFMA standards. There are several standards that are relevant to the educational market. I will affirm that you won't see education in the scope, usually the terminology institutional, and again that applies for educational and healthcare and so forth. Flammability and international work have taken on high priority in recent years. We talked a little bit about the reduction in flame retardant chemicals, and we are trying to work with the international community to harmonize the standards that I've discussed today. We're probably years away from agreement, but that's the goal, is to have one standard for desks globally, one standard for chairs globally, so on and so forth. It sounds simple, but it's just a difficult thing to do. And standards for large people are in the works. So that's my summary, Mike. Thanks for having me.
Well, that's enlightening. I'm known for one who takes a particular interest in very ordinary things. I find that the marquee topics like sustainability aren't, or at least to me, as interesting as some of the overlooked places of campus. And this is certainly one of them. When I go to our property disposition office, this is a place where the various departments take furniture and other university-owned property for resale. And most of the acreage, and I do mean acreage, is devoted to furniture. It's true that there's a lot of computers out there, but when I look at the amount of furniture that the university puts out for resale, it gives you a sense of how much furniture, makes the built environment livable and useful. And so it's not as ordinary as it may seem. It really is an extraordinary component in our total cost of ownership considerations. I had a couple other questions, if you don't mind.
Oh, absolutely, Mike.
Some of it has to do with moving and dimension. So, for example, I know that a lot of people are always moving furniture, and I guess I'm speaking of household furniture, and I think possibly in commercial settings that it's likely that you don't have dimension problem. You're not moving a couch up and down the stairs, for example. But are there any I guess innovations, you might call them, where furniture can actually be separated temporarily as you move them in? Or I know a lot of furniture is constructed, but it just strikes me that one of the areas when you think of buying office furniture, is how do we get it into the office? Any work BIFMA does, or any thoughts you have on how it is that organizations move furniture in and out of the workplace?
BIFMA has no standards or committees that deal with that topic. I've worked for various furniture companies over the years, and I've seen the installers in action. Really, they're professionals. They know all the tricks, how to put things on glides and roll them around, and how to disassemble things. I think the engineering community tackles most of the what you just asked about in terms of, something's very large, it's going to be designed to come apart and put back together. But I think that's on a case-by-case basis, and I'll just say the designs are all very unique, and everyone's is different, and that's what makes them competitive.
Yeah, I imagine so. The University of Michigan has a moving and trucking area, and they're actually rather skilled, as you say. These guys know their business. They know how to detail moving large amounts of furniture in quantity, but also some furniture going in places where you didn't think could actually do it. So I'm trying to think. So dimensions, I imagine, is something that they all are innovating on. Is that what I just heard you say? Are there standard dimensions for, say, a desk, for example? Are there standard dimensions?
Yes and no. There are some very common dimensions, and those would be somewhat based on the ergonomics guideline. You want a seat height to be within a certain range. You want a desk height to be in a certain range, and if it's adjustable, you want it to be able to go, so low and so high and so on and so forth. But that yes and no response. Panel heights, a lot of them are, 42 inches and 60 inches, and there tend to be some commonalities, but there's no standard requirement other than maybe a few things from ADA in terms of, it's got to be able to accommodate certain people.
Mm-hmm. And then finally, and this is probably a question that's really not dealing with furniture standards, safety standards, but one in which you might have some perspective on how the supply chain has been transformed by the internet. Other ways of purchasing, specifying, delivering, how you get a purchased product to the delivery location. How does the specifier go? Say a large institution. They have their cadre of experts, or maybe their contractors, who are given so many square feet, and they design the carpet, the furniture, the fixtures, anything that makes that built environment functional for the occupants. Could be a research project, could be a teaching environment. Is there anything new or innovative that is making furniture acquisition, specification, delivery, and installation any faster, safer, simpler, lower cost, and longer lasting?
It's improving all the time. Difficult for me sitting in the BIFMA office the last 6 years because I've been out of the industry myself for those 6 years. But I witnessed, the customers with design tools that are provided by the manufacturer so they can design their spaces quicker, and then of course the manufacturer will affirm that that can be done. The business and institutional furniture manufacturers historically have dealt with large contracts and still do. So the specifiers, the customers, often have professional staffs that write detailed requests for quotation, and that process, I don't know, has changed a lot, but I do hear from the manufacturers that the online or the shopping via the internet is becoming more of a factor in their business. I think the bulk of it is still the large contracts, but as you say, the use of the web has changed things, and that interaction is a little bit more seamless now.
I'm thinking of a researcher who's received a $10 million federal grant, and now he very often he may or may not be engaged with the selection of the laboratory furniture. I'm thinking specifically of laboratory furniture. The price signals between the user, the funding agency, and the supplier are not strong ones. Very often the furniture is, that part of the project budget is buried somewhere in a line item. And I ask that because sometimes there's a disengagement by the researcher, which could likely mean a certain amount of waste. Maybe the researcher doesn't want to be involved in his own laboratory furniture. Maybe the university or the institution has experts who do that and know the market as well. So that is from that standpoint, knowing how much research. I think we do, I'm trying to think. I used to know this number. It might be on the order of $50 billion a year in research to the largest research universities. I don't think it's more than $100 billion, but I think it's something on the order of, say, $50, $60 billion per year. And a lot of that is, national, federally funded research. And it was always a thought we had, and we were looking at how we might be effective and help driving our costs down. Is how do we, what kind of downward price pressure do we put on the cost of that equipment, either through competition or making the decisions by the end user closer, so that it was within his capacity to make decisions that might be more economical decisions. So, well, okay. Well, thanks very much, Dave. I hope we don't have to wait another year to do this. I know there is some action I think you could tell us a little bit about. Documents that are out there for review, your flagship standard. Is that what you were talking about the other day?
Yeah, the ANSI BIFMA X 5.1 standard is a 2011 standard. It's undergoing its cycle review. ANSI wants us to update these approximately every 5 years. So we're at 5 years right now, and we're almost done. It's going out for a public review. Public review ends January 6, 2017. Or it might be January 16. I'm sorry, I might have that date wrong. But nonetheless, it's available for review, and people can contact me directly to request a copy and provide feedback.
Okay.
Again, that's part of the ANSI process.
Yeah, that's on, I think, on the webpage we set up for this. So I will post this on the webpage, and we'll get it out to you, and others can communicate with you directly. Grateful.
Absolutely.
This does contribute to our total cost of ownership agenda, and for that, I'm very grateful. Thanks, Dave.